thank you.
Thank you.
All right. So hello everyone. I'm really glad that I'm here with you. And thank you, the amazing team of MENA in Tech, for providing this opportunity. So this is going to be on batteries, state of the art and the future technologies for electric vehicles in particular. And before starting, I'd like to talk a bit about my background. I had my BSc and MSc degree from Iran University of Science and Technology at Control Engineering at 2011. And then I had my PhD degree from the same university at 2016. I started my job as a lecturer at Puyash Institute of Higher Education at 2013, then promoted to a senior lecturer at the same university at 2016. And at the same time, I was a part-time researcher at Iran University of Science and Technology. And at all this time, I was working as a control engineer and working in control design and implementation and identification of the dynamical systems until 2018 that I joined University of Warwick Manufacturing Group as a research fellow, and currently I'm working on a collaborative project with Jacksonville Land Rover and the Faraji Institute at WMG. So what we do here in WMG is we try to build a bridge between the industry and the academy. So we try to provide solutions to the problems that industry comes to us with, or we try to propose new methods or new things that are going on in the scientific world and in the academy to them. So here in WMG, most of the projects are focused on vehicle industry and transportation industry. And we have two very powerful teams. One is on electrification, electric vehicles, train, aircrafts, and marine systems. And of course, connected to that, the battery team. Here in WMG, we have very facilitated labs to test the batteries. We even manufacture batteries, we make batteries, and I can say that our labs are one of the largest battery testing labs in the whole Europe. There is one another team on the vehicle, particularly on autonomous and smart vehicles. Probably you have already heard of that. Everyone is looking to make the cars smarter and less dependent to the driver. So driverless, that famous driverless term of the vehicles. So this team is working on that, and they're using very their new and modern type of simulators to create different situations and then train their algorithms to reach that goal. So let's go. So particularly, I'm working on the batteries, and I am more expert on battery modeling, battery control, and battery management system. So let's see what the battery is, and where we stand now and where we are headed to. So today everyone is looking for cleaner and more competitive future, and this is forecasted to be achievable via cutting-edge technologies like hydrogen, bioenergy, industrialization, digitalization of industry. And this clean energy that we are talking about is sought after in different aspects of our lives, forcing us to move towards clean energy production, more advanced transportation systems, more efficient buildings and industries, and well-managed agriculture and lands. So in that big picture that you see here, where the battery and energy storage lies is somewhere around here. So we need this storage systems to store the clean energy that we can get out of solar or wind energy. And obviously we need this energy, we need the batteries to transfer that energy to different applications of the modern world. So this is where the battery stands in the whole picture of the modern world in terms of energy. So what makes batteries particularly very important is their energy trilemma. So the balance that they give us between emissions, cost, and security of supply. So generally speaking, batteries can help us save like 1 million tons of CO2 per year, and they can also help saving electricity costs like 45 pounds per household for electricity per year, and also they can act as a reserve and as a support for our energy system. So they can provide like 133 megawatt of extra capacity to our dispatchable generators. So probably you have already seen batteries. I'm sure you're much familiar with the batteries, and you have seen them in the like that they started to appear and in the that camcorders. Probably your all of you remember them, and then they paved their way into our portable devices. But today at 2020, when we talk about the batteries, it's not only these devices, it's also for storing large amounts of energy coming from renewable sources, and obviously for new transportation systems. So it is forecasted that by 2025, like more than 940 gigawatts demand for electric vehicles will come up, and this will also be like 2,300 gigawatt hours for other type of transportation systems by 2030, which is a huge number. So particularly on electric vehicles, we already know that they are very much popular and very much accepted compared to the internal combustion engine or the normal fuel type of vehicles. And the trend is almost the same in all over the world. And it's expected that by 2040, like 55% of all of the vehicles on the streets would be of the electric type. So when we talk about electric vehicle, what we talk about a normal vehicle chassis, and instead of a fuel tank that you have in a normal vehicle, we have a battery pack inside it. So this is the figure, this is the schematic of the battery pack of the Jaguar Land Rover EV. And this battery pack, which provides the energy for that vehicle instead of that fuel tank, is responsible for over 30% of the mass of the vehicle, the weight of the vehicle, and it's almost responsible for more than 30% of the cost of the production of an electric vehicle, and also 50% of the CO2 emissions that is produced like in the production of the electric vehicle in general. So battery pack is the most expensive part of an electric vehicle, and not only it's expensive, it has one more problem, and that's its lifetime is much shorter than the life of the other parts of that of that vehicle. A normal vehicle, let's say, if lives for 15 to 20 years, not 20 years, 10 to 15 years, the battery pack only can live for 8 years, and that's a short time compared to that the vehicle life. So this is the challenges that the battery in the electric vehicle is encountered, its life and its cost. So when we talk about the battery in an electric vehicle, not only it has these two challenges, it has some other problems with it. So I'm sure that you have already seen different types of the batteries. Batteries can come in different shapes and sizes, but it doesn't matter what shape or size they have. We require them to have some specific, some specifications. So we need the battery to provide us high energy and high power. We want it to be lightweight. We want it to be small. We want it to be safe. We want it to live long, to last long, and we want it to be cheap. So when we talk about the electric vehicle with all these specifications, there are different type of materials and like chemistries that can give us this requirement, that can provide us this type of requirements. But the thing is, lithium ion is one of those materials that can give all of this together. So that's why everyone is talking about lithium ion battery. So lithium ion battery can provide us a good lifetime and a good power density. So what's going on inside the battery? So a battery is made up of different parts. So it has metal and metal parts that can like convey the electrons, and it has two chemical parts that we call them positive and negative electrodes that contain a material that has lithium inside. So when you connect a battery to the charger, the the material decomposes and it produces lithium ions and also an electron. That electron is the electricity that you get out of the battery, and that lithium is the ion that transfers and helps this process. So this is what is happening inside a battery. So when we talk battery, and at the other side we talk about an electric vehicle, there is a long way in between. So batteries are normally very small, like 7 centimeters if they're cylindrical, and they are very low in voltage and also in capacity. But when we talk about a vehicle, we talk about a system that requires like 400 volts. So how we need to scale up that 5-volt batteries to like 400 volts, that's the question, and that's the challenge. So we need to connect this together, we need to make packs, and we need to put it into a vehicle. And this comes with a lot of challenges. So you know that there are vehicles already on the street and you're using them, and probably they're working very well. But there is a lot of things going with that, and although they are very much acceptable, but there are still things that are required to be improved with them. So these challenges of battery can be divided into 2 sections: challenges in the manufacturing and challenges in the control. And by manufacturing, we mean how we make the battery, how we manufacture the battery, what type of material we should use. And when we talk about the control, we want the battery to perform well, to stay safe, and to live long. So at each of these directions, there are lots of things going on. So when we talk about the cost of the battery, in the past 10 years, the cost of the production has decreased, as you see here, very considerably, but it is still costly. And most of this cost comes from that positive part of that battery. So still research is going on about understanding what type of material should be used to give us a low cost battery output. And the other thing is that some of these materials can give us a good range of voltage and good range of capacity, but the problem is some of them are very expensive, some of them are very unstable, and that's why it's the top secret, like saying of a manufacturer, how to choose this. When we talk about how the batteries work and how the batteries perform inside an electric vehicle, when you put batteries inside an electric vehicle, as I mentioned, a normal battery is like 5 volts and a capacity of like 5 amp hours, but like Jaguar I-Pace requires 400 volts and the capacity like 100 kilowatt hours. So what happens is you need to connect like thousands of cells. So for example, in Jaguar I-Pace, as far as I know, there are 3,000 cells. So what happens here? You have 3,000 cells connected to each other and at the bottom of your vehicle, and you need to understand how they're performing. If their temperature is okay, if there is still enough energy left in there, because you don't want to be left without energy at the middle of the road. So you should have a proper indicator of the energy of your battery pack, and you should know how long is left of your battery, how many more years your battery can live. So this is the part that we control the battery. We measure its signals, and then we try to use algorithms in a small computer that we connect to our battery pack to help it perform well. So when we talk about measuring signals of that battery, we talk about lots of challenges. So as I mentioned before, a battery pack can contain 1,000 or between 1,000 to 3,000 cells. So it's not possible to measure each and every single of the cells. So it's really important. Why we cannot do? Because it's costly. You cannot put like 3,000 current cells, 3,000 temperature cells. For example, I can say that a good current sensor costs like 2K, 2,000 pounds. So imagine that if you need to connect like 2,000 current sensors to your pack, how costly it would be. So the question is, we need to decide where to put these sensors and how to get the information and how to use them to help the battery work well. The other thing about the battery that is very much important is how it ages. Probably you have noticed that when maybe it's easier if I give an example of your mobile phone. Probably when your mobile phone is brand new, so when you connect it to the charger, you can charge it like in like 10-20 minutes. But as it goes, after a few months, after a few years, the charging time will take longer and longer. And the same is for the discharging. When you use it, when it's brand new, it takes like hours coming from 100% to like 20% of charge. But after a while, it just drops from 100% to 20% like in like 20 minutes. So that's what we say, that's what we call aging. At that point, your battery is aged. So the problem with the aging is that it takes time for that huge battery pack to get aged. And it's really important to understand that at what point that will happen. So what people need to do is we need to provide a forecast of that aging. For example, if a manufacturer is selling a car, for example, for Tesla or for even Jaguar I-Pace, I know that the guarantee for that battery pack is like 8 years. That's exactly the time that after that your battery is gonna die. So where does that the 8 years comes? It comes from the modeling based on normally machine learning. So people or researchers put these batteries onto different scenarios and they gather the data and then try to forecast the performance over time. So the thing about aging is it is one of the most important things going on with the battery, because if you don't forecast the aging of your battery well, when you sell your product to the customer after a few years, it may like lose its capacity, lose its performance, and it's really costly to change that battery pack for your customer if you haven't like provided a good time of guarantee or warranty for your customer. So this is one of the most important things about the batteries that is still going on in the research, and is one of the most important problems for it. The third thing that is going on regarding the batteries is about the performance and is about the safety. Battery is a chemical material, so it has metallic parts, it has chemicals inside it. There is a separator between positive and negative side that is very toxic. So, and it's very small in size generally, and it's very sensitive to the pressure or temperature. So the thing is, the last thing that we want is having a battery under pressure and having its gases or fumes out of it and having it exploded. So the thing is, we need to control the battery properly and we need to cool down the battery uniformly to avoid this kind of problems. So not only we need to have and design a proper cooling system for a battery, it can be air cooled, it can be oil cooled, or any other type of cooling, different type of chemistries in that coolant. So the other important thing is that we need to cool the battery uniformly, because as the battery gets warmer, it ages sooner. So probably you have noticed that, or not noticed, probably you've been told that don't put your mobile phone on a very hot area. The thing is, when you heat up the battery, the chemical reactions start to speed up, and then it loses that amount of lithium that is left in it, and the side reactions cause the battery to lose its performance. At the other side, we don't want the battery to be cooled very much, because when the battery is cool, the reactions cannot start, so you can get energy out of it. And that's one of the major challenges that we already have regarding the usage of electric vehicle at the colder areas like Iceland or some part of Canada, because you need to warm up the battery and you need to bring it to a predefined temperature and then use it. So neither cool temperatures nor the hot temperature are good for the battery, and both will cause the battery lose its performance over time, or let's say it will age. So these are the most important things about the battery. And although there are lots of things going on still. There are lots of things without an answer for a battery. So currently electric vehicles are in the market, and the very first generation of them will turn 8 years old, the time that companies has warranted them. So they will soon mm, pull off the road, and will be studied to understand what has happened to them during this 8 years. But it's still definitely aging the main concern that is regarding the battery pack, because when your battery pack ages, it loses the capacity and it takes longer to charge, and it discharges sooner. And this is the one thing that you don't want about your battery. The other important thing about the battery is its charging time, which limits the application of electric vehicle very much. When we talk about the charging, for example, a normal Jaguar I-Pace takes like 13 hours to charge. So compare that with the normal fuel type of vehicle that you go to the fuel station and just fill it up within like 10 minutes, within like 4 minutes. So compare 13 hours to that, and that's a long time. And this is the issue. The next issue with electric vehicles is still, and there are lots of researchers going with that. With this, there are two solutions: either change the algorithm that we charge the battery, but currently I know that there are a few startups that are working on that, because that algorithm is very important, and how you charge the battery is pretty easy. You don't need lots of facilities to design that algorithm. And the other thing about that is the chemistry itself, which is still under a study to understand what kind of chemistry will let you to charge your battery faster. Researchers are talking about taking that time from hours to minutes, like 15 minutes. But yeah, there is still a lot of challenge with that. So it's expected that there's going to be soon there's going to be some type of fast charge battery. So if you haven't yet bought an electric vehicle, I'm sure that you're going to be able soon in the next few years buy one which is easier to be charged. And the other thing is about the charging stations itself. Currently in UK, I know that we have like 8,000 locations compared to the 9,000 locations of the fuel stations, which is very good. But still, we don't have any rapid or fast charging stations, and this needs to be considered when if it's expected that the electric vehicles, if it's expected that they are going to occupy a huge share of the vehicle on the road. The cost is still higher than the normal fuel type vehicles, but it is expected that it's going to drop massively in cost in the next few years. Probably you have noticed that yesterday it was the battery day of Tesla, and Elon Musk was saying, because they claim that they're going to provide electric vehicles under $25 grand. But yesterday they said that, okay, we're not going to have it until 2022 or 2023. But so it is expected, but we're not still there. And so, yeah, I'm just saying that if you haven't bought yet, you can wait, and you can wait, just wait. There is going to be massive changes in the next few years. So the other thing that might be very much interesting, not from the engineering point of view, but those that are working on life and human sciences, is the range anxiety that we call. So people haven't yet accepted electric vehicles much, because they feel that they're gonna left without charge at the middle of the road. Yes, that's true. But if you charge it at night, and if you use it for daily use under like 300 miles, it would be okay. and it's not going to happen, but people just don't believe it. And that's some kind of psychological problem that people are studying it. I know that, for example, in Warwick, there's our psychology department that is studying it. So what is the reason for that, and how they can help people accept electric vehicles. And the other thing is the battery performance. About the battery performance, as I mentioned, it's really important to manage the battery signals that you get. When we talk about measuring the energy left inside the battery pack, I'm not sure if you know, but inside the fuel tank of your electric vehicle, there is a physical sensor that senses the level of the fuel. We cannot have something like that for the battery. We cannot drill the battery and put the sensor. Yeah, people do that, but not in an electric vehicle. As I mentioned, there are thousands of them. So there are some control and modeling method going on in that, and this is a very good area of those that are looking for small companies and small startups to focus on improving the battery performance. And the final thing that has come to the light very much recently is the battery recycling and waste management. As I mentioned, first generation of EVs will be back to like warehouses with their battery pack should be removed very soon. So the key question is how we're going to recycle. When we talk about the recycling of the battery, we're not talking about opening up the battery, taking the material out and then using it somewhere else. No. A battery pack of an electric vehicle is cold aged and old and should be replaced when it reaches its 80% of performance, which is a large number. You have 80% of the battery energy is still left at it, and you say that, okay, we cannot use this inside an electric vehicle. So what happens to that battery pack is the key question. And there are some, again, I know that there are some projects and there are some startups. A few days ago, there was a UK-based startup, particularly that has started working on this recycling. So they call it second-hand applications. So they take the batteries that come out of the road, out of the vehicle, for other type of applications. Like they can use it for household microgrids, or if you have a PV at your home and you're using battery for it, this type of batteries are very well suited for those type of applications. And we also, the other problem is the waste management. Battery contains very toxic and very harmful material, and it's really important how to manage it. So there are going to be soon lots of batteries out of the cars, and there should be proper ways to manage them. So yes, these are the main challenges of the battery, and hopefully I've given you that initial thing to, so if you are interested, you can follow it. If this has already got your point, got your attention, and you want to know more about this, there is a very simple video on our department website that will give you introductory thing about the battery. And also, if you are a control or an electrical engineer or are working in machine learning, you can take a look at these two books. I'm going to copy this link in the chat box so you can have a look at it. So, well, yes, thank you for listening, and I will be more than happy to answer any questions if you have.